Okay, so let's get started with um well, time flies, it's October already. So let's get started with WasmEdge community meeting. And we have three items in the agenda. So we'll get started with Haidai about the newly released WasmEdge 0.14.1 and what we can look forward to for the 0.15.0. So Haidai, please.
Okay, great. So I'm doing the 40.1 review, and so let's go into the highlight. And this, I believe, two new roster bed. Uh, these two are different applications, but they are based on the same roster. If you are familiar with that, and you would like to add more application based on this framework, create a pull request and issue that, hey, I have I would like we are very welcome for the ideas. Also, one important thing, we support the stable diffusion plugin, stable diffusion in the diffusion model and the flux model, and they both support GPU on the Mac OS or Linux with CUDA. Yeah. And we all have an experimental for the LM.C, which means you can use our plugin to train in a GPT-2 model, and just based on the LM.C project. So our highlights of the 14.1 version, and what's new if we move to the 15.0. And actually, we'll have two more fuzzy neural network backends. One is the MLX framework from Apple, and TensorRT framework, from NVIDIA. So with these two backends, one you can leverage more Apple provided model, and the other that will run some based on the CUDA architecture. And we figure out that if you are using the tensor bring more performance improvement, if you are using the same model which is using the so we believe if you are based on the CUDA architecture, you can get some benefit from this backend. And we will, provide the virtual file system support for the plugins. So I believe it will bring more, secure environment for the especially Watson neural network model, because that you can find that more and more plugin which will rely on multiple models. Models will, provided by the NM option. And we believe that if we can add all of the models, such as the multi-model, the lava model, which will rely on one different models, and with this feature, it can be more secure if we load this model from virtual file system. And also we have two new, related features will be shipped during the 15.0. One is the stock section, and the other is the resource type. And we believe that once we have these two more fundamental features, that we can start merge the place WASI Preview 2, and we are still focused on implement all of the WASI HTTP proposal relative proposals. Yeah, and the last one is that we already deprecate all of OS 7 essays, so we won't have the support start from the release. So that's all of our review and what's new in our next version. Yeah, so that's all. Thank you.
All right, thank you, Hadai. Yeah, that's so as you can see, we have a lot WasmEdge or AI related stuff. So I also understand that WasmEdge standard is changing over time. So move to the next phase of the WASI standard. So so one of the interesting plugins that we demoed in our last meeting was Stable Diffusion. A lot of people have talked about that and asked us about Stable Diffusion support because that's one of the most used use case for AI, right? So over the last month, we have significantly improved support and also performance of this particular plugin. So for our next speaker, I ask Vivian to come on and give us a demo of our latest advance of text to image generation. Vivian, please.
Thank you. Can you see my screen?
Yes, I see your internet.
Okay. Can you see my?
Yes.
Okay. So, as I mentioned before, we released the WasmEdge 0.1 last week, and one of the most exciting features is that we add Stable Diffusion plugin support. So we can run the Stable Diffusion mode, also the FLUX model on our own machine, generate the images. So compared with Stable Diffusion, FLUX model has better performance, but it will long time. The machine that I demoed today is my own MacBook Air. It only has so generating generating an image on my machine will take almost 3 minutes. So I will send the API request firstly, and then go through the whole tutorial. As you can see, this is the API request to generate the image. The API server is also OpenAI compatible, so you can integrate the OpenAI based framework. So Arms is a beautiful white woman dressed in a medieval costume and in the dark forest. And there will be also a sword in her hand. Let's see let's see the image generated by FLUX. So I will send API request. Here is the command line to run the FLUX model. As you can see, the WasmEdge Stable Diffusion plugin start to go through the whole process, how to run. So I will switch to the this tutorial. This tutorial is legency.io /articles/FLUX.1/ so this is link, and you can follow the article to run your own machine. So the first step is that to install the WasmEdge 0.14.1 version. Using this because the Stable Diffusion support is stage, so you will need to manually install the Stable Diffusion plugin. But if you are running a text llama model, you don't need to do that. Our installer will handle the process. So depending on your chip. With the mental support, it will increase the generation. If you have CUDA and CUDA in your hand, you need to download the diffusion info, then unzip the plugin. there is one thing that to pay attention to, that is the WasmEdge plugin is with the Stable Diffusion plugin on the Mac platform. So if you are running the FLUX plugin on your MacBook, you will need to use this command line to remove WasmEdge. But Linux, there is no conflict between WasmEdge and the Stable Diffusion plugin. So you just need this plugin. And the next step is that to download as 4 models, and those models have different roles. So for the main model, the FLUX.1 model is responsible for text image generation, and the AE-F16 model is a VAE file. It will compress and decompress the image, and the clip model makes the textual prompts with image, and the T5 access will process and encode the text prompts. So we will need to download those 4 models. And then we will need to download the SD API server can run it across different CPU and GPUs. If you're interested in the source code, it's also written in Rust, and we compiled it into Wasm. The GitHub repo is here, and if you are interested in to check out the source code, and besides the FLUX, we also can run Stable Diffusion models. You can just follow the README on this repo. But to be honest, has better image. Okay, so right now we have the WasmEdge Stable Diffusion plugin. It's the runtime for FLUX model, and we also the model files, and we also have the API server program. So the next step is to start the API server. And go back to my terminal. So as you can see, I use this command line to start running the FLUX. And for the FLUX server will run on the port by default. You can also change it by adding the command line. So from the log, we can see that they generated. From model start to generate the image, and the entry to the image generation ends. It's almost 2 minutes. So let's go to my let's go to check the image. Okay, here is the image generated by the FLUX model. It's beautiful. What it has 2 source lines.
We didn't see the photo.
Oh.
Yeah, I can see the image.
So you can't see the image.
I can see it.
Okay. Yeah, so this is the image generated by FLUX. And in this article, we also two image examples and put the prompts in the article. And if you are interested, you can try. I think one more thing. So So because I my machine only has 16 gigabytes, so I only can run GGUF format GGF format models. If your machine is with bigger RAM, you can run the safe tensors file model, and you can just simply replace the GGUF the safe tensors file name, and then I think you will get a better image. Okay, that's all.
All right, thank you, Vivian. Yeah, that's so I thought that capability is really good, you know, and also add that's the image NVIDIA GPUs. That actually shows you, although the Mac GPU has larger memory and is generally very good for large language model, but when it comes to image generation and and things like that, performance really matters. So the NVIDIA GPU could be a lot faster. Yeah, so if you have a NVIDIA GPU, you could like a 4090 be a lot faster. That means, although we have you can generate image like Vivian, but it's not HTTP request and then get back in the HTTP response. It's not really not like that because applications can't wait, for the HTTP for a couple minutes. You time out by then. Structure you have to build so that it's and then provide some kind of asynchronous alert that you download after the fact, right? So that's something improve and functionalities to the to developers applications. So that's with people in the community, and so hopefully we'll have something else to demo in the next community meeting. So yeah, so those are very good, and then I think our next George is in this meeting, but I made a recording, right? So it's one of the other model or plugins that people have always asked for, which is image but text, so the TTS plugin. And so Vivian, would you be able to demo this for George, or
Yes, George has recorded a video for us. So
That's excellent.
yeah, where we have so many demos in the community because of the new version. Okay, my screen.
Yes.
Hi, I'm Cao Hanwen. Today I will introduce the WasmEdge plugin, ChatTTS backend. This is today's outline. First, we will introduce the ChatTTS. We will introduce how to install dependencies and build. Finally, we will run an example. This is the WasmEdge many example of the WasmEdge in this report. It also includes ChatTTS backend. All the tutorial and example code you can find in the report. Chat-to-speech model designed specifically for dialogue scenarios, such as LLM assistant. ChatTTS backend is the one of WasmEdge plugin backend on ChatTTS to develop a backend following WasmEdge API that can generate other WasmEdge plugin backend. ChatTTS also follow. If you have used other WasmEdge, you may get started quickly. Start demo. We need to install some dependencies. Because ChatTTS is developed by Python, we will use Python C++ API in our backend. Then we recommended using pip to install ChatTTS. If you have another version required, you can adjust by yourself. If you want to use other accelerated library, you can install them together in the step. The next step is in the first, you need Edge and change the directory to the source folder. Use the following CMake figure project. In order to install, you need to set ChatTTS as WasmEdge plugin WasmEdge backend value, and build and install WasmEdge. The next step is to build our example code to WasmEdge. Use cargo build to build WasmEdge to run the Wasm. Our ChatTTS provides 6 API. The load API is to load ChatTTS and in a graph. In need execution context is to create a text. Set input is used to pass the input prompt to context generation. Then compute function to generate the sound. Use get output to get an array from the backend. When you want to start the ChatTTS, you download to release the Python resource. I want to use ChatTTS again. You need to call load, otherwise you cannot use other functions. It is example code. We set a prompt to it is a test sentence for ChatTTS, and we want to change it to audio. We will ignore UV black for now. It is a special token which we will introduce later. Then because ChatTTS will auto download the model and the load, so we just pass an empty array to the backend. Next, we call init execution context to create context, and the call set input to pass our prompt and use compute to generate a result. Finally, we use get output to get the array. We use a RAS audio library to the audio array, change the audio array to. Then let's start a quick demo. In the first, we use cargo build to build the Wasm. Then we use WasmEdge to run the Wasm. You can see that because our computer only have CPU, so it use CPU. Then it start to generate the audio. You can see that it generates a web file, then output. Because it is a remote computer, I cannot directly play the audio. So I play a result I generate before the demo.
It's a test sentence for ChatTTS.
Then let me talk about the control token. In the first, we play original sound.
It is test sentence for just ChatTTS.
If we add up at the beginning of the sentence, it sounds like this.
It is test sentence for.
You can hear him loud at the beginning. And if we insert UV break between sentence and the forward,
it is test sentence for just ChatTTS.
A small break. How about we change UV break to L break?
It is test sentence for ChatTTS.
You can hear it has a noticeable pause in the middle of the sentence. So you can use the control token to let your generated sound have more emotion. Next, we have more advanced option you can set. You just use the set input function and set the index to 1. There are 5 options you can set. The first one is pump, which will generate a special text to synthesis. The special use as you can refer the example code. Next is SPKEMB. It is a sample speaker. You can use it to add a sample speaker. If you pass a random it will randomly generate a speaker. The next 3 parameters, top K and the top P, for generating and the sampling process. The demo. Thank you for your listen.
All right. So, yeah, this is this plugin is already ready. So if you are interested in using OpenAI like text to voice, adding this capability to your application, you should be able to use that now. So one of the issues, however, from my end, is that it's still some dependency. So for people who's already use, so you can use this together with your other applications. But for people who's already using Python, it could be a difficult. It could be difficult to convince them to switch to using Wasm and Rust this way, right? So completely not dependent on Python. Meaning that the um, the encoder and decoder and things like that would be written in a lightweight or faster language that doesn't have to our say that type of plugins where you can just use WasmEdge plugin with very more roadmap. Maybe we'll have the revisit of both demos next month. To have a stronger TTS demo that we can connect them together with with large language model to build a complete application. Maybe. So anyway, so I guess that's it for all the talks that we have for this community meeting. And if you are watching this on the internet, that's where issues, just raise a. We'll see you there. Okay. So is there anything else that anyone want to add? Okay, I think that's it. And see you next month.